Yes, welcome back to the session. In this video, I'm going to discuss about force due to thin rod along the axial line. So this topic is most important for especially NEET as well as JEE. Okay, let's say for example, we have a straight uniform rod contains a positive charge. Okay, and the length of the rod will be L, linear charge density will be lambda. Okay, now let's say for example there is a point P which is located at a distance R from the one end of the wire. Okay, now what I'm going to take here, I'm going to take a test charge Q naught which is placed exactly at point P. Okay, so whenever two charges was present, then automatically Coulombic force of attraction or repulsion will be exist between the two charges, right? Yes, so here we have one charge Q and the test charge will be Q naught. So definitely there must be Coulombic force will be developed, correct or not? So it is very difficult to calculate for entire length of the conductor. That is the reason first I'm taking a small length element. Let's say for example, this is the length element dx which contains a very small amount of charge dq. Okay, so this length element which is located at a distance x from the point P. Okay, now I'm going to calculate first of all Coulombic force. So Coulombic force which is given by 1 by 4 pi epsilon naught into the first charge will be dq into test charge will be q naught by the total distance of separation I'm taking here x square. Okay, as we know that linear charge density lambda is equal to dq by dx, correct or not? So from this dq is equal to lambda into dx, right? Correct or not? So this formula I'm going to substitute in the above expression. Let's see. So F is equal to 1 by 4 pi epsilon naught into, so dq means q naught lambda into dx by x square. Okay, so this is the expression I got. Now I'm going to integrate the above expression. Let's say for example the constant terms and all I'm taking outside. Let's see, so which is equal to 1 by 4 pi epsilon naught into q naught lambda integral over 1 by x square into dx. So here the integral limits I'm going to take from the total distance of separation here r to L plus r. So L means length of the conductor, right? So we can write it as r to L plus r. Okay, let's see, which is equal to q naught lambda by 4 pi epsilon naught into, how to write this one, 1 by x square we can write it as x power minus 2 into dx, which is varying from r to L plus r. Okay, as we know that integral x power n dx is equal to x power n plus 1 by n plus 1. Am I right? So here the expression will be in the same formula, right? So I'm going to convert. Let's see. So q naught lambda by 4 pi epsilon naught into x power minus 2 plus 1 by minus 2 plus 1, which is varying from r to L plus r. So therefore q naught lambda by 4 pi epsilon naught into x power minus 1 by minus 1. So this minus 1 I'm taking outside and x power minus 1 if it goes to denominator means 1 by x. So therefore minus q naught lambda by 4 pi epsilon naught into 1 by x, which is varying from r to L plus r. Okay, so first I'm going to substitute L plus r. Let's see. Minus q naught lambda by 4 pi epsilon naught into 1 by L plus r minus 1 by r. Now I'm going to rearrange the steps, then automatically this minus will be cancelled, right? Let's see. So q naught lambda by 4 pi epsilon naught into 1 by r minus 1 by L plus r. Okay, so this is the total force acting on the rod. Okay, I hope you understand. Thank you so much.